Hey everybody, and welcome back to another fun and exciting intermediate math class. In today's lesson, we're going to be starting on the last chapter of the book, chapter 12. So yeah, give it up. You guys have been working hard this year. So go ahead and turn there in your book. That's going to be on page 486, page 486. And go ahead and look down here at the screen. In today's lesson, we're going to be talking about inequality notation. You might be saying, why do you have a white screen today? Usually it's a black screen. I know. Just wanted to change it up a little bit, and you'll see in just a second we're going to use some number lines. And so the number lines that I'm using kind of show up better on this light-colored screen. But let's go ahead and jump into the lesson. What is an inequality? Well, it's exactly what it sounds like. It's something that's not equal to. So, for example, you might have that 3 is some relationship to the number 4. Now, you can't put that 3 equals 4 because that's not true. Now, notice from this list of inequalities that we have here, we could kind of look at some different ones. And maybe multiple ones can fit that. So, we know that equals doesn't work, so we can't use that. Is 3 less than 4? Yes, it is. So we could use less than. That would work. Is 3 less than or equal to? Yes, it's less than, so we could use that one. Is it greater than? No, it's not. Is it greater than or equal to? No, it's not. Is it not equal to? Yeah, that one works too because 3 is not equal to 4. So in this list of 5 different inequalities, 3 of those actually worked for this one. So we could say less than, or equal to, or that it's not equal to. So let's write, how are we going to do that? So we can't use the equal sign. That's not going to work. So what are the different signs for these? Well, let's go through this. Less than points to the left. I think that's the easiest way for me to tell you how to write the less than sign. So it's like an arrow, right, pointing to the left. One way that you could do that is you could say that it's pointing to the smaller number. I don't like that way. Let me show you the way that I like to do it. I like to make this guy like a Pac-Man, right? And you could even give him some teeth if you want, right? And he's going to eat the bigger one. Yeah, I know my drawing is terrible. But why is he going to eat the bigger one? He's going to eat the bigger one because, let's say, your parents buy pizza, and you and your brother are sitting there, and they say, okay, get a piece of pizza. Well, which one do you want to get? Do you want to get the smaller one? Of course not. You want to get the bigger one, right? You want to eat the bigger pizza. So the little sign here, this little, less than, greater than sign, whichever one, it always eats the bigger number. That's the way I like to remember it, okay? So the less than is going to point to the smaller number. It's going to eat the bigger number. The other way that I remember this less than is that less than points left, less left, okay? So sometimes my brain, I have dyslexia, so dyslexia makes me switch things around a lot. So for me, this is a really hard thing to remember sometimes, like, okay, which way does less than point? And so I really have to think through some of those things. So hopefully that helps you. Less than points left, and it always eats the bigger number. Less than or equal to, that's the next one. So we have a less than sign, and we also would have an equals underneath of it. Now, it's not like 2 lines for an equal sign, it's just 1, but if you kind of look at just that bottom part, it does look like an equal sign, okay? So that's the less than or equal to. We could also use that one here. This one works because 3 is less than or equal to 4. The next one is greater than. So the greater than sign points to the right. Okay, now I know less than left, greater than right. Yeah, sorry. I don't have a good letter there for you. So it points to the right. Now, if we were to switch this around and put 3 on the other side, so if we put 3 over here, then we could use that and we could say it's pointing to the right. Remember, it always points to the smaller number. and it always eats the bigger number. So this greater than sign is still eating the bigger number. The sign always, always, always eats the bigger number. And that's the easiest way to remember it for me. All right, so maybe you're thinking, that's silly putting teeth on that thing. It just helps me, okay? So maybe it'll help you. Then for the greater than, we would have a greater than sign and then the equal sign underneath of it. So that would be greater than or equal to. And then the last one is not equal to. And we could also use that one right here because 4 and 3 are not equal to each other. The sign for not equal to is an equal sign with a line through it. Put the equal sign, put a line through it. That means not equal to. So we could come up here and say that 4 is not equal to 3. And that would work as well. All right, so the next thing that we want to do is we want to talk about this dude right here. This is the number line. And so with any number line, for the most part, we're going to be starting at 0. That's going to be kind of our middle point. When we go to the right, these numbers are getting bigger, right? When we go to the left, these numbers are getting smaller over here. So going to the right, bigger, going to the left, smaller. If I have negative $2, that is a smaller amount of money than $1. It's a smaller amount of money than negative $1. So it's a smaller amount of money than $0. Because for every number I go in reverse, in backwards, I'm owing you more money. So $6, negative $6 is a smaller number than negative 1. And that's kind of weird, right? Because 1 is smaller than 6. But in negatives, negative 6 is smaller than negative 1. So it's whichever way we're going on the number line. So if we're going to the left, those are getting smaller. If you're going to the right, those are getting bigger. All right, so now let's try to graph something here on this. So let's just say that x, we're going to graph x is greater than 3. X is greater than 3. So here's what we want to do. We want to go to our number. This is our what's called a critical number. So we're going to go to our critical number and we're going to circle our critical number. So come over here to the 3 on the number line. We're going to circle the number 3. Now if you look down at the bottom of page 486, it says that there's a difference between an open dot. So this would be an open dot. And we'll just call this open. And then this is a closed dot. So when we color it in, this is closed. Now, open dots are for when it is not equal. And closed dots are for when it is equal. All right, so now what does that mean? Here, this does not have an equal with it. So it's not greater than or equal to. If it had this, if it said, x is greater than or equal to 3, then we would use a closed dot on that one. But this one's not. The one that we're doing is called an open dot. So we would go up here and we make our open dot right there on the critical number, which is the number 3. That's the critical number because that's the number that we have in our problem. So x is greater than 3. So what numbers in this case, what numbers would work for x? What numbers, we'll call it, satisfy this inequality? What if x equals 4? Does that work? 4 is greater than 3. That works. What if x is 2? 2 is greater than 3. No, that doesn't work, right? So what you're wanting to do here is kind of test, if you will, what numbers work. 4 works, 2 does not. So look over here. 2 does not work. So no numbers on this side work. 4 does work. So all of the numbers over here are going to work. So we're going to color in on our number line all of these numbers. Now be careful not to color in your dot because 3 does not work. So check this out. Let's go up here and let's look at this. So if I, instead of 4 is greater than 3, what if I put 3 is greater than 3? No, 3 is not greater than 3. So this needs to be an open dot to show that that's not part of the solution. Now let's change this just a little bit and let's now say that x can be greater than or equal to 3. Well, if it's or equal to 3, then guess what? 3 works. You could say 3 is greater than or equal to 3. That's true because 3 is equal to 3. So we would color that in now, and that would be part of our solution. So you close the dot when it is also equal to. You open the dot when it is not equal to. And then you might say, well, what about this one? What about if we get that it's just not equal to? Well, if you get that, then the answer is graphed, and let me kind of erase everything and show you that. So x is not equal to 3. Now remember, the open is when x is not equal to that. So you would still, remember your critical number is still 3. You always come to 3 and you circle it. So here's the thing. Everything else worked, right? 4 is not equal to 3. 2 is not equal to 3. Everything else works except for 3. 3 is the only thing that doesn't work. So in this case, you would color in this way, and you would color in this way. So you'd color in everything except for the 3 would be open because 3 doesn't work. 3 is the only number that does not work in this example. All right, next thing that I want to look at in this lesson is compound inequalities. What is a compound inequality? Well, what's a compound sentence in English class, right? A compound sentence is when we have more than one sentence that's combined with something. There's a conjunction. We say, you know, Bob went to the store and he bought milk. Okay, so there's two sentences there. Bob went to the store, he bought milk. And it's connected with and. So if you look at this, we have two different inequalities. There's an inequality and there's an inequality. And if you look, they're connected by this x in the middle. So this is what's called a compound inequality. So you say, well, how do I do these? So these ones can be a little tricky when you're drawing these out. So you can't just say, oh, you know, I'm just going to put my mark and then I'm just going to draw my line in there. It's not that easy. You have to really think these out. So let's come down here and let's actually graph this compound inequality. -2, that's where I would start right there. Is I would say -2, this is what's called what? It's called a critical number. So I'm going to come to my -2 and I'm going to circle it. Now, if you look at this right here, we're circling it and we're going to color it in because it's also equal to. So I can come right down here and I can go ahead and color that dude in right there. Then I can come to 4 and I can say, okay, there's my other critical number. So I'm going to come to 4 and I'm going to circle it and I'm also going to color it in because it's also equal to. So there we go. I have my two critical numbers right here and I have them circled. Now, here's where the little trick comes into play. And you might say, oh, I'm just going to follow the arrows, and I'm just going to draw these, and I'll draw this, and I'm good. Everything is good. No, everything is not good. So what do you need to do? Here's what you do. I pick test points, and I pick them on all sides of my critical points. So look, here's a point over here. Here's a point in the middle. And then here's a point on the right-hand side. Does that make sense? So here's my critical points, right? So I'm going to pick a number on this side, a number in the middle, and then a number on this side. Okay? Any number will work. It doesn't matter which number that you pick. I just happen to pick -4. I could also pick -6 if I wanted to. That would also work. But I just chose -4. Now what do you do with it? You take the -4 and you sub it back in for x. -2 is less than or equal to -4 is less than or equal to 4. Read that and tell me if that's true or not. -2 is less than or equal to -4. No, -2 is greater. Remember, I said these are the bigger ones going this way, and these are the smaller ones going this way. So -2 is actually bigger than -4, so this doesn't work. In other words, you're not going to color this in over here. So this doesn't work over here on this side. Now let's try the number 1. Let's see if the number 1 works. -2 is less than or equal to 1. is less than or equal to 4. Is that true? -2 is less than 1. Yes, that's true. 1 is less than 4. Is that true? Yes, that's also true. Good news, this one works right here. Okay? Now, let's try the last one. So we'll try the number 6. -2 is less than 6. True. 6 is less than 4. No, wrong, false. So the way that I do this is I would come down here and I would say, okay, in this middle section, these ones all worked. So this is where I would draw my line and I would connect those two. So basically I'm saying that anywhere in between these numbers, anywhere between -2 and +4, that solves my equation. That works. So I'm going to use those numbers. All right, and believe it or not, that's all I have for you in this lesson. Kind of some basic concepts, but really important concepts as we go forward in algebra. I know you're not in algebra yet, right? But you're working toward it. We're getting there. So as we go into algebra, you're going to be using this all the time. You're going to need to know how to graph. You're going to need to know how to use inequalities. In the next lesson, we're going to learn how to kind of get an inequality by itself, almost like solving it like an equation. So, and that'll be the last lesson for this book, and then we'll do a bunch of review, and then you'll take your final exam. So keep working hard, do your best, practice these. You're going to need these in the future. All right, that's all I've got for you. You have a good one. We'll see you later. Bye-bye.